Hey. All right. Hello, welcome back. Me and the world's neediest dog are just sitting here doing our thing. Hey. All right, give a couple more. Hey. Hey there. You're being a little clingy. Yeah. She's afraid I'm gonna leave, because usually around this time I go to Greenville Tech and teach. So she gets a little separation anxiety. So the strategy becomes literally lay on top of me so I can't go anywhere. Okay. Let's go ahead and start. Okay. We are starting our unit on memory. So memory and learning, like I said a little bit in the past, are very closely linked. They are pretty much to do any kind of, to commit anything to memory. It's just kind of learning that sticks around for a while. So we're going to start with a case study. We're going to come back to this guy a good bit because he's just really interesting, especially when we start talking about amnesia, which is memory loss. So Clive Wearing, he was a musician and also a conductor of other musicians. I think the composer that he was studied the most was a guy called Lassus. So he developed in 1985 this viral encephalitis. Encephalitis, we talked about that a little bit, I think, back when we talked about chapter 2 and epilepsy and all the different ways that you can treat it. Encephalitis is one of the things that can cause epilepsy. But it can also cause significant damage to an area in your brain like the hippocampus, which damages your ability to create what we call explicit memories, which is memories that you can recall readily. So he did recover physically from this viral infection, but the virus damaged his brain a whole lot. So he's lived in an assisted living facility for pretty much the rest of that time, because he can't remember how to do a lot of things and doesn't remember a lot. The big thing with Clive Wearing is that he can't create new memories. So he does have some memory of his past, like a pretty vague outline of how he got to be where he was. But he does not have the ability to create new memories. Okay. So you can kind of see how viral encephalitis works on this scan. This isn't of Clive Wearing's brain, but it's just kind of a good visual image here. The cause of the swelling is herpes simplex virus, which is what happened in Clive Wearing's brain as well. It's pretty rare, only happens about 500,000 people. So this is not the STD herpes. This is one of the other simplices of herpes. This is the same kind if you've ever had a cold sore that can be caused by herpes simplex 1. So just imagine a cold sore in your brain, basically. Okay, so what is memory? All right, so memory is brain processes involved in encoding, storage, and retrieval of information. So there's no one way that we can all kind of agree as students of psychology that oh, this is how memory works. But there is a basic understanding that the general processes, which is basically those 3 words there, encoding, storage, and retrieval, is how we get to having things in our brain and having the ability to recall them when we need them. All right, so what do those 3 things mean? The first one is encoding, process through which information enters our memory system. So For something to make it into our memory banks, it has to first be encoded. It has to be associated. So we've talked about classical conditioning. That's one of the ways. It has to be associated with events are converted into neural activity that travels to the brain. So we are constantly getting sensory stimuli. As you guys are listening to this, you're watching TV later, what have you. You are having things pass through your sensory memory, and we would call that encoding. Some of that is actually going to be stored, but we'll talk about how that works. There's two ways that this can go. It goes into the memory system if your brain deems it important enough to make it there, or it gets lost. It just kind of gets tossed out because we're constantly taking in sensory information. Thankfully, not all of it makes it into our memory system, because that would be exhausting and it would be difficult to make heads or tails of anything, because your brain is going to keep the stuff that means the most and that is most important for its survival. All right, process number 2 is storage. Okay, so once you've got it encoded into your brain, you want to keep it there. So if you think about it, like if you have a file on your computer, this is, and if you've downloaded a file, you're going to put that file in a special folder so you can save it for later. Okay, so that is storage. Once we've got it downloaded, which is encoding, we need to store it in a particular folder. Storage, that is the process of preserving information for possible recollection in the future. So this is what the encephalitis virus messed up for Clive Wearing, because he cannot store new information for later. It just goes away very quickly. If you've ever seen the movie Finding Nemo, which if you haven't, I would recommend. Dory is a good example of a sort of short-term memory loss being represented in popular media. This is a good example of a storage failure. So you can tell the person, or the fish in this case, bits of information, and that just kind of doesn't quite make it to the point where they can store that in their brain. All right, the last one is retrieval. So once it's actually in that folder, we need to be able to recall it if we need it. That is the process of accessing information encoded and stored in memory. Retrieval failure is when you are trying to recall something or recognize something and you just can't quite. You've ever had that, we call it the tip of the tongue phenomenon. You've ever been like, oh, I can't quite remember what that is. There's a good crash course video on study skills. And so if I were to ask you what this is the example they use, if I were to ask you what the capital of Finland was, you may not know off the cuff, but if I were to tell you that it starts with an H, you might be able to come up with Helsinki, which is the capital of Finland. So not being able to remember it without that hint is called a retrieval failure. And then actually giving you the hint is through a process called priming, which we'll talk about later, and using a retrieval cue to get to that information. All right, so the question here is, how deep are your memories? The deeper level of processing you use, the more likely you're going to be to actually remember whatever it is you're trying to remember. And there's 3 levels. So there's shallow, intermediate, and deep. The study they're using is sort of being represented visually over here on the left. They showed a bunch of subjects a fish, and they were showing the 3 different levels. They gave them the word fish, and they were trying to remember what it was later. So they had, give them the word fish, and then 30 minutes later or whatever, ask them whatever that word was. So the first question they asked was the word like capitalized? Did it have like a curvy font, or was it more like block letters? So that's shallow processing, because that doesn't actually mean anything. That's just like basic physical features of the word itself. Intermediate processing, they would ask, does it rhyme with something like stump? And they would say no. And then we get to the point, does it rhyme with something like dish? And then they say yes. That's intermediate processing, because we have at that point kind of connected it to 2 different senses. So, you have the auditory sense of being able to figure out if it's a rhyme, and then also the visual sense. And then deep processing is actually connecting it to something that means something. So let's say you had a goldfish growing up that you were particularly attached to. So we would say that that is deep processing, because you have an emotional connection to that particular word. You can form that visual image in your head and then remember the word because of that. So that helps with long-term storage and long-term retrieval, being able to have some sort of personal connection to it. So like if I asked you what the capital of Helsinki or capital of Finland was and you'd been to Finland, you'd be able to remember that a little bit more easily because you have a personal experiential connection with it. That makes sense. We call that deep processing. Okay, so I mentioned there's no like universally accepted model of memory. This is one of those models. It's been updated a good bit since it was originally postulated. So this is from a guy or two guys, Atkinson and Shiffrin. This is their information processing model. You've probably heard a little bit of this before, but there's 3 stages. So you have your sensory memory stage, short-term memory stage, and your long-term memory stage. So your sensory memory stage is that place where you're like, I mentioned it earlier, where you're just like constantly being bombarded with sensory stimuli. Like you have 5 senses, they're all working all the time. So like in this moment, you're smelling stuff, hearing stuff, seeing stuff, everything is on basically. But thankfully, not all of that is being processed at any kind of deep level, because if it were, you'd be exhausted all the time. So that's sensory memory. And that only lasts like a couple of seconds, like especially if it's not something that you're actually going to use. Your body says, okay, nope, don't need that, get it out of here. Now, the stuff that is relatively important, we would say that makes it into your short-term memory. So your short-term memory lasts about 30 seconds or so. And this has a slightly greater capacity than sensory memory for stuff that can be processed there. This is the thing that Dory struggles with in Finding Nemo. If you remember, like when she and Marlin meet for the first time, he gives her the whole story about Nemo and how he got taken away by this diver. And then she immediately forgets it. So that's within about 30 seconds, that information was already gone. So somebody has short-term memory loss is going to not make it to this 3rd step, which is long-term memory. Long-term memory is the stuff that sticks with you. It can be either explicit or implicit. We'll talk about that more later. But you can have short-term memory issues and not have long-term memory issues, and vice versa. You can have long-term memory problems and then be able to keep things in your short-term memory. So that would be a good example of like Clive Wearing, who can keep things in a short-term memory, but they just go away after a certain amount of time. Long-term memory also incidentally has the biggest capacity. You can remember a whole bunch of stuff in your long-term memory if you can, get it to make through those first couple of stages. All right, sensory memory. There's 2 main types because we are predominantly sight and sound based creatures. So like Mei, if she remembers things, it's usually through her nose, because dogs have very, very good olfactory memory, very good smell memory. Humans are going to be more sight and sound, and the sensory memory breaks down into 2 categories. So we'd say iconic memory and echoic memory. The iconic memory is the visual short-term memory that we can keep like a perfect image of something that we see in our head for a very short amount of time. And then echoic memory is the auditory version of that. So it's an exact copy of the sound that we hear. Okay, this is George Sperling did a very famous experiment on this. Checking to see, he would flash, like if you can see the circle on the left, he would flash that entire thing up for his subjects to look at, and then he would be, all right, repeat the whole thing. And most of the time they couldn't do it because we have a limited capacity for how much we can keep in our head. But if they focused on one line, as you can see on the right, they were able to remember that a lot more effectively. And this was also true of auditory information as well. They played 3 tones. It was harder for people to remember as opposed to just playing 1 tone. Now, there are people who can remember like just a ton of information from a very short amount of exposure to it. So we call that eidetic imagery, ability to see something once or twice and remember like colossal amounts of information about it and replicate it well. They use the example here of you've ever probably seen somebody who it's like claimed to have a photographic memory. That's not exactly a thing, like really in psychology, but eidetic imagery is similar to it. All right, short-term memory. You can see this is one of the important graphs that we'll talk about. So the stage of memory that temporarily maintains and processes a limited amount of information. So you can see that as the time goes on the x-axis, the amount that a person is able to get correct relative to a letter series that they were exposed to goes down. So short-term memory, the accuracy of it decreases pretty sharply as time passes. You can extend the duration with an idea called maintenance rehearsal, which is the technique of repeating information to be remembered. So going back to Finding Nemo, there's a part in that movie where they are trying to remember a very key bit of information, which is the location of where Nemo is in Sydney, which they find on a diver's mask. The diver that rescued Nemo is not the right word, but stole Nemo might be the better word there. Fished him out of the ocean. But the address is P. Sherman, 42 Wallaby Way, Sydney, which you might remember because Dory, to keep it in her memory, repeats it over and over and over again. Okay, like there's an entire scene where she just does that constantly to try and keep it in her memory banks. And that is called maintenance rehearsal. So that's not actually shifting it over into long-term memory. If she kept doing that over a series of like days, it might. And she also has an emotional connection to that address. So like it might work that way. I've seen the movie many times. And so, and I have an emotional connection to it. So I remember the address. But keeping it in that short-term memory so it doesn't go away is that idea of maintenance rehearsal. So whoever like had somebody tell you their phone number and you were like, didn't have anything to write it down with, and you were like, and the way that you decided to keep that in your short-term memory until you could write it down was just to repeat it to yourself. What role does attention play in this process? A pretty significant one, because if you're like me and you are clinically easily distracted, that is going to make that significantly more challenging, but also helpful. All right, I think, all right, yeah, we'll do working memory and then Miller as well. Okay. All right, what's the capacity of short-term memory? Not a ton. So this is going back to chapter 1. We discussed this a little bit. George Miller had this idea of 7 plus or minus 2. That is generally the amount of information that we can keep in our working memory at one time. So you can see on the left, this digit span test. So the digit span test is they just keep adding numbers until the subject can't remember all of them anymore. And the people that do the best at this are typically the people that can break these big numbers into chunks. This idea called chunking. It's not just one big piece of information. It's a few pieces of smaller information, smaller bits of information. Yeah. So doing this, a phone number is a good example because like you have, so you can see this like 0128957 like that's not, it's 7 numbers technically, which is right about at the limit of your short-term memory, according to Miller, but you can break that up into a section of 3, into a section of 4. It's a lot easier to remember. And that's typically how we remember phone numbers. And this is another good strategy for keeping things in your short-term memory. All right, working memory. So working memory is an updated version of the process we talked about up here. So the information processing model. This is more in-depth. And there are 4 pieces to it. And all this is in your short-term memory. So there's your phonological loop, which is going to process auditory information. That P. Sherman 42 Wallaby Way, Sydney thing is a good example of that because it's a loop. You're just trying to keep something in your short-term memory by continually repeating it. Getting that auditory stimuli, your visual spatial sketchpad. So you do create a visual image of it as well. Your episodic buffer, which kind of helps you decide what to do. And then your central executive, which is kind of the point guard and decides which thing does what. I will probably explain that more in the Kahoot when we do it, because this is kind of one of the more complicated ideas we're going to do. But you can kind of see episodic buffer specifically. The guy is asking, do we need milk? Because like if you go in to your fridge and you see like either the list itself or just like scanning the fridge quickly to see what you actually have in there. You remember the conversation you had with your significant other about bringing food home. Your episodic buffer is going to say, okay, well, what do we need based on that? And your central executive is going to direct your attention to whatever area needs to be figuring out what to do with. So if you're like listening to an audiobook, your phonological loop is going to be engaged more because the auditory information is the most important. If you're watching a presentation or a TV show, your visual spatial sketchpad is going to be involved in that more heavily. And then the central executive decides which one is going to take over. All right. That is all I have for you guys today. I know we're cutting out a little bit early, but like I said in my email last night, I'm not feeling super great. So I'm gonna go take some meds, drink some tea. I will keep you guys updated. Like I said, assignment 3, if you've already done it, don't have to worry about anything. If you haven't done that discussion yet, please do that. As long as you guys have both of those done by this Sunday, you will be good to go. So if you have any questions about either one of those, please email me. But other than that, I will see you guys next Wednesday.